So I'm explaining the first page of our write-up. Let fx be continuous over the semi-infinite interval, this one. Okay, so 0 less than equal to x less than infinity. Then the improper integral of fx from 0 to infinity dx. This is defined by limit of this definite integral fx 0 to r dx, and when r tends to infinity. When this limit exists, then the improper integral is said to converge to that limit. This improper integral converges to the value of the limit, okay, if this limit exists. Similarly, if fx is continuous for all x, that means x is between minus infinity to plus infinity, we define this improper integral from minus infinity to infinity of fx as sum of these two limits. Remember that this is note that this is from minus r1 to 0 fx dx, and this is 0 to r2 fx dx. This is when r2 tends to infinity, and this is r1 tends to infinity. If these two limits exist, then we call that this improper integral converges to the value of this sum of these two. Okay. On the other hand, we can also define another limit, this one. So you see that this is minus r to r fx dx and r tending to infinity. Here we had two limits and here only one limit. If this single limit exists, then the value is called a Cauchy principal value of this improper integral, and we write that as PV of this improper integral, right? Principal value, PV means principal value. So that is, principal value of this is defined by this single limit, okay? And remember that there are differences between 1 and 2. There are two limits here, and here there is only single limit. Okay. So in the next slide I will show that what are the differences between 1 and 2.